I want to take a chance to do another solve by elimination just to show you what happens if you have to multiply top and bottom by a different number to get them to eliminate. So if I'm looking at this equation of 1.5 x plus 2y equals 20 and then 2.5 x minus 5y equals negative 25, I got to determine what variables I want to try to drop out. Do I want to try to eliminate the x's? If that's the case, I'm really looking for the least common multiple between 1.5 and 2.5. And since they're decimals, it probably makes it a little bit more difficult for me, so I can think of it as 15 and 25, and those are pretty large numbers, so I'm going to take a look at the y's and see if I got a better selection there. I've got a 2 and a 5, and now my least common denominator between a 2 and a 5 is a 10, which is a lot smaller than trying to find the least common denominator between 15 and 25, which is probably 75. So kind of choose wisely if you want to make life a little bit easier on yourself. So what we want to do is we're going to attempt to eliminate the y's, and in order to get the y's to eliminate, I got to multiply the top equation by, and it's not showing up very well, so I'm going to take the top equation by 5, and I'm going to take the bottom equation times 2. So as I rewrite those, they'll show up a little bit better. 1.5 x plus 2y equals 20, and I want to multiply that one times 5. The bottom equation, which is 2.5 x minus 5y equals a negative 25, I want to take that equation and I want to multiply by 2. As long as we multiply the top equation by the same value and the bottom equation by the same value, we create equivalent equations. So, performing this, we got 5 times 15. 5 times 15 looks like it's a 75x. Oops, 1.5. So it's 7.5x. And then 5 times 2 is 10, so we got 10y. And 20 times 5 is 100. On the bottom, we've got 2 times 2.5, that's 5x. Then we got negative 5 times 2, which is negative 10y. And then we got 2 times negative 25, which is negative 50. Okay, so now what we've done is we've accomplished our goal of getting these, at least one set of variables, the y's, in opposite signs. So now when we add these two equations, the y's are going to eliminate. So we're going to take 7.5 and add to 5, which is 12.5. x, and that equals 100 minus 50, which is 50. So then I'm going to have to take the 50 divided by 12.5, which is 4. So we know x is 4. So now we're going to go and we're going to plug that back in either the first or the second equation in order to find the value of y. So we're going to use substitution principles at this point. So what I know so far is that the x value of the ordered pair where they collide or the lines meet is 4. So I'm going to choose the top equation, 1.5 x plus 2y equals 20. I'm going to replace the x, since this was the x value that we found, to help me find the y value, and that means I can take 1.5 times 4 plus 2y equals 20, and 1.5 times 4 is 6, so 6 plus 2y equals 20. And then we're going to subtract the 6. So that means 2 times y has to equal a 14, and that means y is 7. So our ordered pair is the ordered pair 7, 4, and that is the solution to our system of equations. So thought I'd run through an example with some decimals in and something where you'd have to multiply top and bottom and then add.